But Peter, I need the pre-roll to give the computer time to catch up and avoid all this jittery frame. Good morning, everyone. Okay, now first thing. I have generally, over time, been doing an acknowledgement of country, but I'm going to do something just a little bit different this time. One thing I've been doing consciously for a little while to help me see different perspectives on things is following as many Aboriginal people as I can on Twitter, so that I see their perspectives on things. And so I'm going to do a quick shout out to Main Wyatt, who is he's an actor. Some of you may know him from Neighbours, and he's seen a whole lot of crap in the entertainment industry and is not afraid to tweet about it. So he's a very interesting guy to follow. Anyway, so today, okay, you would have seen that the live stream was jittering quite a bit when it started, but that is not going to be the case for very much longer because yes, I finally got one. Thanks to everyone that contributed to that GoFundMe. I'm not actually using it right now. This is just the box for it, but it is set up. It's on the back desk there behind those microscopes, and I spent about a day with it doing things like synchronizing Dropbox and installing software and getting it set up. I don't have a proper monitor for it yet. That's the next thing I've got to get. But I do have an M1 Mac Mini, which is going to make everything a whole lot better. So because of the limitations of the way the Mac Mini video works, I can't do the monitor setup that I've got here. So what I'm going to do is get a single 49-inch ultra-wide to replace the three 27-inch monitors that I've got here now. One of those monitors isn't a monitor actually, it's just the iMac. So it's going to all get a whole lot better. I may not end up running the live streams directly from the M1, and I'm probably going to run them from a secondary computer combined with the, where is it? Just over here somewhere. Oh, here we go. Combined with the ATEM Mini, which, as you can see, I'm not using right at this moment either. It's not plugged in, but I'm going to have that for switching multiple inputs, like switching between the overhead camera and the microscope and other sources, and then feed that in. Mute my phone, Peter is telling me. Yes, well, if you if you weren't messaging me, then I wouldn't be getting these alerts. Okay, mute. There you go, Peter. Are you happy now? I'm really hot in here. I had the heater running because it was freezing cold when I walked in, and now I'm all rugged up. So now it's stinking hot. So, all right. I've got a few random things today, and just as a starting point, I'm just going to show you something that I've been doing with Chris. Now, as many of you know, I've been working with Chris for a few years now, doing accessibility type projects, assistive technology, and a lot of it has been around wheelchair hacking. And yeah, anyway, this is a fun little thing that is a variation on a theme. Let's see if I can do a, where are we? Desktop. Okay, switch to the desktop. Okay, so this is a thing that we've just been working on. And the thing is that a lot of what I show you with these sorts of projects, you might get the impression, hey, you've done that before, why are you showing us that? It's the same thing as last time. But there are some projects where we do similar things but in different ways, or we do it with a different type of integration. So it looks like, oh, you're controlling a chair, but you've done that before. And But the thing is that it's being done with an entirely different method this time, which gives us some advantages of what we've been doing last time. Now, in the conference talk at LCA that Chris and I did 2 LCAs ago, we showed a wheelchair being controlled using a game controller. So I was on the stage and the wheelchair was down the front on the floor, and I was remote driving it using a game controller. Now, the way we did that was we replaced the entire wheelchair control system. There was nothing at all of the original chair electronics involved in controlling it. With that system, what we had was the battery pack supplying power to our own motion controller that we designed, and that was driving the motors. It has a CAN bus interface, so then we had a Raspberry Pi sitting on the back of the chair, and the Raspberry Pi was sending CAN messages to the motion controller, and then the game controller was paired with the Raspberry Pi, and then there was a Python script that was reading it, etc. So it was very invasive. If you start with the wheelchair and you want to be able to remote drive it, this is like the most invasive way possible of modifying the chair so that you can make it do what you want. And what I'm about to show you is it's another way of achieving the same end result in some ways, but it's being done in a totally different way, and it is the least invasive, probably the least invasive way of doing it. And it's much simpler electronics and much cheaper, etc. Much easier, and it's all based on an ESP32. So with this method, well, I'll just show you this video. I'll hit play on this, and I'm just I'll mute myself there so that you can see it. But you can see that I'm using so I'm in Chris's bedroom here. You can, down on the bottom right, you can just see the front of his chair. He's sitting there looking in this direction. So I'm using, in this case, a PS3 game controller, and I'm driving the chair using the right joystick. Now you can see that sitting on the tray of the chair is a little, just down here, is a little circuit board. And there are 2 cables coming out of it. This like zebra stripe black and white cable, that's a USB cable, but all that's doing is providing power. That's plugged into a mobile phone charger port on the chair. So the chair is providing its 5 volts, the USB connection, and that's providing power to the board. That's all it's doing. No data or anything involved. And then on the output side, you can see this grey cable. This is a DB9, so it's just basically like an RS-232 cable. It comes out of there and it plugs up into here, which is the input port on the chair's controller. And you can see there's a black cable here hanging down. So that black cable is the cable that comes from the joystick that normally drives the chair. You can see down here there is the little joystick. You can see the cork knob on the top of it. So that's the joystick that normally drives the chair. It sends a signal up into here, and that's how you move it around. So the point of all of this project is that this little board just here, I didn't mean to do that. Let's make it big again. So this little board just here is being a fake joystick via this cable, and it is sending signals to the controller that make it think that you have a joystick plugged in and you're moving it in different directions. And that's how it's making the chair move. Now on that board is an ESP32, which has Bluetooth on it. And then the game controller is paired via BLE. And we're running, so there's a sketch on it, like an Arduino sketch basically, on the ESP32, which has 2 libraries in it. One is for a PlayStation 3 controller, one is for a PS4 controller. So you pair the controller with the ESP32, and then you can drive the chair, which is actually really remarkably useful. It's In fact, in this view, you can see up the back, on the back of the chair, you see this little joystick up here. There's this box that's mounted on it. Now this is called an attendant joystick, or an attendant control. And there is a button up on the back here so that if you need to move the chair around without being in it, then you can walk up to the back of the chair, you grab this joystick, and then you can move the chair. But, and that's really useful. So once Chris is out of the chair, like if he's got into bed, for example, you want to be able to move the chair and put it out of the way. You don't want it sitting there, right there next to the bed in the way. So it needs to be moved off into the corner, or, something. And these chairs are heavy. They weigh like 200 kilos. You can't push them, so you can't move them manually. So you really need to be able to drive them in attendant mode to move them around. And one thing that I found is that when I'm trying to move the chair using the attendant joystick, because the chair is moving, your hand is on a joystick which is moving with the chair. You get used to it, but it's actually kind of awkward because you're not standing still with the joystick, fixed position relative to you. You have to walk, and the joystick is moving. It's constantly moving away from you or moving sideways as you're driving the chair. So you have to kind of brace yourself against the chair, like have your hand held against the base of the joystick while your fingers are moving it. Otherwise, the act of moving the chair makes the joystick move, which then moves it in your hand, and you can see where all of this is going. As I said, you get used to it, but it's annoying. And so being able to move a chair like this with a controller that you just hold in your hand and you're not physically connected to it, you can just pick up the controller and drive the chair around. It's really, really easy. It's super convenient. So yeah, you can, if you need to, you can just walk along near it and drive it with the game controller. So this has been, so far, it's probably one of our more successful and useful projects, which is quite cool. In fact, maybe, let's see, I'll close that. This is something I'm going to get to in a moment. This is something that Aaron has been working on, but first, let's have a look at, Gerald said probably safer to operate. Yeah, I think it is. JNet Reloaded said put a stand on back of chair, then simple really. Yeah, I actually do that. And JNet also asked where's the code for the ESP. I'll show you, it's all on GitHub. So these particular chairs, so these are, it's a Permobil F5 Corpus, I think is the type of the chair. I don't know why they call it Corpus. It seems to be a terrible name for a wheelchair. Hang on, I'm just opening Eagle at the same time. Yeah, so the way they work, these particular chairs are front drive. So the main drive wheels are at the front, and then it's got dolly wheels at the back. The dolly wheels are on metal arms that stick out the back. So one way that I often do it is I just stand on the back of the chair and directly above the dolly wheels. In fact, I wonder if you can see it. No, I've closed that video. Oh, hang on, let's see if we can get back to it. I'm using an unfamiliar keyboard, so I have to think about what I'm doing. Was it Command Tab? QuickTime Player. Yeah, I should be able to get to it through Open Recent. Open Recent. This one. Now, let's see if there's a spot where you can see the back of the chair. Oh, you can just see it there. Just about there. That's a good spot. So you can see this part of the frame of the chair sticks out the back, and you can see there's like an articulation point for suspension and the dolly wheel on the back. So when I'm moving one of these chairs, I often just stand on the back of the chair and drive it along in a standing position while I'm holding onto the, like bracing myself on the chair and holding onto the joystick. But yeah, being able to do it like this with a game controller, it's even better. Means I don't bash my head on door frames going through them. Because standing on the back of a chair like that makes me like 7.5 feet tall or something. So door frames are a problem. Or 7 feet tall. So now what am I looking for? That's right, projects. This one is called PWC, Permobil Wheelchair Controller. And so also just as a I hope people don't mind that I talk about these sorts of assistive tech projects. I really like them. They're technically interesting and they're beneficial to do. So yeah, it's not quite mainstream home automation, but it's home automation adjacent, and yeah, I just love working on them. Yes. Matt Smith said, I think corpus just means body. Yes, exactly. That's why I think it's a bit of a bizarre name for a wheelchair. So where are we? So the actual model, no, where is it? Permobil Corpus F5. Yeah, this is the type of wheelchair. Surely they could have come up with something better than Corpus. Yeah, anyway, that's the model. So this is the controller, and it's kind of small. So that's a Vroom 32 module that you can see on there. No, I did not put an SP32 on it directly because I am super lazy, and for $3.50 or $4 or whatever it is, I get a module with an antenna and everything ready to go. Plonk it down, and I don't have to worry about QFN and antenna and flash memory and all the other things that you normally have to do. So it's got the connector on the right that goes to the joystick. There's the USB-C connector here, which can be used for flashing. And also the other thing is that this means we can drive the chair using MQTT or whatever else you might want to do over Wi-Fi. So that's kind of cool too. So we can send MQTT messages to the chair and have it respond. So there's also an input on this board for the zero stick. So the idea with this, the way this is set up, is that the joystick on the chair is replaced, the regular joystick is replaced with the zero stick, which is the zero deflection joystick. And then this interfaces with the chair controller, and it can take commands from multiple sources. So you can either use the zero stick, so the joystick, to drive the chair, or you can use a game controller over BLE, or you can control over Wi-Fi using MQTT or whatever other mechanism you like. So this becomes like a universal input to the wheelchair, and you can send it command, like movement commands or whatever, from all these different sources. So it's the way it's set up at the moment is in the code, if it detects that it is paired with a game controller, then it locks out the joystick. And so it starts up looking for the joystick by default, and then if you activate the controller, that takes over. So you don't have two inputs fighting for the same thing. 88 miles per hour. Yes, Matt. We are going to send it to the future. So, engage flux capacitor. What am I looking for? What am I looking for? Oh, okay, yeah, I'll show you the schematic of this. It's got some kind of interesting parts to it. There is, most of it is pretty straightforward. this is the first page of most of my projects ends up looking very similar. So we've got USB-C connection, USB serial converter, so I've just got a CP2102 on it, the auto reset circuit that you can't quite see because my face is in the way, the voltage regulator, and the ESP32. So, you know, page 1 of the schematic is the generic stuff that has nothing to do with the specifics of the project. It's just the microcontroller and how you talk to it and power it. And then on the second sheet, we've got the interesting things. Let's see if I can just bring that across sideways a bit so that you can see it all. All right, so this is the stuff that is specific to it. We've got the zero-stick joystick input here, which is, it's actually just an I2C header because the zero-stick has its own onboard stuff to process the load cells and measure how hard you're pushing on the joystick, and then it just reports that via I2C. So that's the four-way connector that you saw on it. There is a connection to chair power because we get 12 volts from the chair controller. Unfortunately, we can't use that to power the board. That would be fantastic, but the chair controller will only deliver up to 100 milliamps at 12 volts. And if we try to draw enough from it to run an ESP32, the chair controller freaks out. It doesn't like it at all. So we use this as a voltage reference, but we don't draw any power from it. And then speed control, which is the y-axis, so backwards and forwards on the joystick. What we've got is a couple of DS3502s. These are digital potentiometers. So they've got an I2C interface. And then you can see over here on the right, it's got RH, RW, and RL. This is high, wiper, and low. These are like the 3 pins of a potentiometer. And, Austin's Creations asked, what if you use the chair for a LiPo battery charging? I don't think that would, that's a very interesting idea, good lateral thinking, but I don't think it would solve the problem because the 12 volt output on that header is only available while the chair is turned on, and while the chair is turned on is when we want to be controlling it. If we had 12 volts available at 100 milliamps continuously, and it was just always there, then we could use that to charge up a LiPo and then use the LiPo to run the ESP32. But unfortunately, that power goes away when the chair is turned off. So yeah, this is derived from a few months ago. I showed a chair I2C interface board that I did as well, and this is actually based on that same circuit. So it's really just an expansion of it. So that little I2C interface board was always intended to be a bit of a test. It was trying to figure out whether we could fake the joystick input to the controller using an I2C interface, which would then allow us to do things like exactly this project here. So what we've got is the 2 digital potentiometers, and you can see the outputs of them, the wipers from the potentiometers, both feed across this way, and they go to the connector that goes to the chair. So speed out and direction out are the 2 connections going to the chair for the y-axis and the x-axis respectively. And the voltage reference, which is coming off the voltage divider here. So we've got 12 volts supplied by the chair. We're splitting it in half with an extra bias resistor, and then feeding it into the chair as the reference voltage. So the 2 axes are voltages relative to Vref, plus and minus, what's the number? I wrote it down here, plus or minus 1.2 volts. So we want it to vary between 4.8 and 7.2 volts on the output is full scale on the joystick. Yes, I wrote notes to myself in the schematic. Excuse me. Notes to myself because I forget these things. I work them out once and then I'll come back to it a year later and think, why is it doing that? So yeah, now I can just look back at my notes and remember, I figured that problem out, and that's why. And yeah, more notes there in the schematic. So that's it. So it's actually really remarkably simple when you look at it like this. So this part of the schematic, as I said, this is all boilerplate. You could copy this sheet into almost any ESP32 sort of project that I do, and it would be almost unchanged. As you know, any project that's got USB-C and an onboard regulator, etc. This sheet is the same, and this one, that's just a header. So you know, there's nothing exciting there at all. This is just an LED to show that there's power. And over here we've got two digital potentiometers with their outputs feeding to another connector. And that's it. When you look at it like this, it's actually a really simple project. So yeah, there's not all that much to it. And the whole thing, so the reason it's this strange shape is that I designed it to clip into a plastic box, which we've since done. In that video, the PCB was just sitting on the tray because that was one of the first tests we did with it. But then I made the cutouts in an enclosure and clipped the PCB into it. So now it's in a little black box and it can be mounted on the chair, and it looks like it's just part of the chair. Pretty cool. Now, someone was asking about source code. Scott said, Home Assistant chair control, HA update. Oh shit. Yes. Oh, Doji said, would it take much to convert to a regular remote control? So by regular remote control, I assume you mean, well, there are a couple of things there. Do you mean something like a TV remote control, which is infrared, or do you mean a remote control like a car or aeroplane remote control? And if the first one, that would be easy to do technically, but it wouldn't work very nicely because you couldn't do any proportional control. With the game controller, you got full proportional control for speed and steering and everything, and it's awesome. You could do it with an infrared remote, but what you'd have to do is set it so that if you held down like a right button, then it would just turn right at a certain rate, and a forward button, it would move forward at a certain rate. That'd be better than nothing, but it's not as good as full proportional control. If you mean a thing like a radio remote control, yes, we've already done that. I don't know that I've got much I can show you without, I'd be wasting your time going digging, but yes, we have done a lot of messing around with RF style remote controls. A Fly Sky, yes, Dodgy says like a Fly Sky. Yes, that's exactly what we've been doing. We use a Fly Sky i6, I can't remember. Yeah, oh, Aaron says single-handed Wii nunchuck would be great. Means you can walk alongside Chris and communicate when going somewhere. Yeah, Wii nunchuck, yes, true. And because they're like small and you just hold it in your hand. Yeah, interesting idea. Thanks, Aaron. Yeah, that'd be, in terms of form factor, I think that would be better than the game controller. Game controllers have got lots of inputs and you don't need it. You don't need dual joysticks and all the buttons and the D-pad and stuff like that. You just, in this particular case, all we need is one joystick. That's it, nothing else. All right, nunchuck is I2C. So yeah, we could just plug it in. Having it cordless is nice. Is there a wireless nunchuck? Yeah, I've got an old Wii here. No, that's right. No, we gave it to my niece and nephew. Used to have a Wii here, so I don't actually have the nunchucks and things anymore. But the nunchucks plugged into the handheld controllers, I think, with an I2C interface. I have interfaced nunchucks with an Arduino before. With the RGB LED cube project, I did a version of Space Invaders that was 3D, and it came through the cube, like the alien spaceships flew through the RGB LED cube, and then you use the game controller to shoot them down. So I did that with the Wii Nunchuck. That was 10 years ago, I think. But yeah, Nunchuck is wired. Okay, that's a pity. If there was a wireless Nunchuck, that would be brilliant. A small, like fit in your hand, single joystick type thing. And they've got accelerometers in them too, so you could drive just by tilting, which would also be cool. Now, someone was asking about source code. So, yes, let's get to that. GitHub, and it's on PWC. This one? Yes, okay. So if anybody is interested in checking this out a bit more, I will drop this link in here. And so this is, yeah, well, what do I say? This is it. In fact, you can get a better view of it here in this picture than you could in the video. So the board just has the header for so this is the I2C header, which you could plug a nunchuck into. And the output, you can see down here, these two chips, these are the digital potentiometers. And over here is the USB to serial converter, voltage regulator. That's it. Very simple. And in here also is, yeah, all the hardware is there. All the firmware is here. And what have we got? So, config. Yeah, we've got options. So in firmware, you can enable and disable different input methods, like the zero stick, PS3 controller, PS4 controller. And I don't know why, but I've got an option in here for disabling the output. I can't even remember why I put that in. That was probably so that I could put it into a test mode where I enabled debugging for the inputs and move the joysticks around and things and see the values that it's reporting, but it doesn't actually drive the chair. But I don't even know why I would have bothered with that, because all you do is turn the chair off and then it's not going to go anywhere. But yeah, so I've got options for debugging on the different inputs and the output. Yeah, calibration factors, and oh yeah, this is for pairing it with the game controller. So what you have to do is use a helper utility like 6-axis pair, and you match the MAC address that is stored in the controller to the MAC address of the I was going to say the word controller again, it becomes confusing. The controller in this case, by controller I mean the wheelchair controller, so our board with the ESP32 on it. I'll call it the PWC. So the MAC address in the game controller that it is bound to has to match the MAC address that is in the PWC. So what you do is use an app. You plug the game controller into your computer, you run the third-party program, and you can reconfigure the controller and make it bind to a different host. So in this case, this is how you do it. Anyway, if anyone's actually doing it, you'll need a better explanation than whatever rambly thing I just said. And calibration values for the outputs, and these are just, yeah, different things. So the actual code that drives it all is pwc firmware.ino. Once again, a whole bunch of explanation at the start to remind myself, so that a little bit down the track I know what I'm looking at. Like reminding myself of which way the axes go, and dependencies and all that sort of stuff. What else have we got? Oh yeah, Running Median is a really cool library. I think I've talked about that before. Probably won't go into it now. Bunch of global variables. I'm not going to go into all of this in detail now. It's probably not a very exciting thing to be looking at on a Sunday morning. So do some setup. It looks for the digital potentiometers for the outputs, sets them both to the middle position so the chair doesn't move, which is kind of important. And yeah, blah, blah. Oh, down here. Here is where it enables the two types of controllers. So it can support either a PS3 controller or a PS4 controller. And so you can enable either. I've never actually tried enabling both. I don't know what that would do. Interesting. And then just the stuff that does the stuff. So yeah, I won't go into all the details of that. There's some mapping to allow the scales to be correct on the outputs and constraints so that we don't go outside what the wheelchair can handle. And debugging info, zero stick stuff. I'll ignore that. Ignore that. Oh yeah, reading the battery in the game controller if it's a PS3. This came pretty much right out of the example for the library. And reading the input position, and like for the which one is this? X-axis. So we're reading the X-axis position of the joystick, and then doing all the mapping to adjust it to the percentage scales. And Y-axis mapping, PS4 is basically the same thing, and that's it. That's the end of the sketch. So it represents a bit of jiggering around, like to get it to work the way I wanted it to work. It did take a little bit of time, and yeah, there were a few things that were kind of frustrating. Ended up soaking up quite a few hours of messing around and experimenting with the way with a couple of aspects of it. Experimenting with the way the game controllers worked and how to get the scaling to work neatly with achieving close to full scale deflection without going out of bounds. And so that's why these constraints and scales and all of this sort of stuff is in there. Dead spot in the middle, so that because the thing is that the game controller joystick, it doesn't always return to dead center. It can be just slightly off, and even a small amount off means that the PWC is going to try sending a signal to the wheelchair that says the joystick is slightly moved, and then and then the wheelchair will sit there, because the way they work is they've got solenoid based locks on the wheels, or brakes. So what you have to do in the wheelchair controller is fire the solenoid to release the brake, and then engage the motor to move the chair. That's a safety feature, so the chair can't move unless the controller is actively trying to move it. But what happens is that if you've got the joystick in a position where it's just slightly off center, and the chair thinks that it's like just on the borderline of moving, the solenoid brakes go chunk, 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 and they just keep flicking on and off because it's right on that point of triggering. So what we've done is put a dead spot in the middle of the joystick, and yes. If input dead spot size is less than that input position, else if, I'm looking at this logic now, if -1, so times the input dead spot size, is greater than, okay, so what this is doing, yes, this was one of the things that took a little bit of screwing around. Maybe this might actually be worth mentioning, because it's it's one of those things that when you understand the problem, it's not that difficult, but if you haven't seen it before, it can get you. My very first, and this particular problem, I didn't actually solve this now. I solved this problem a couple of years ago with another project, which was, funnily enough, using a FlySky remote control to control things. So what we yeah, that other thing that was involved in adding a CAN bus interface into the back of the FlySky transmitter so that we could control remote control devices using the wheelchair controls. So that was the other way around. But with this particular thing, okay, so back on topic. Okay, I've got to stop. Articulate the problem. The problem is, based on what I just said, with the joystick being dead centered is the objective. If it deviates from center, then you want the chair to start moving. Now, the dead spot in the middle is the part of the range where you do not want the chair to move. And just imagine, say we're going on a scale here of 0 being the center, minus 100 being fully left, plus 100 being fully right. I mean, I'm just using arbitrary numbers here for the sake of the illustration. Say you want the dead spot size in the middle to be 5 on either side of it. So if the joystick is like -3 or +2 or whatever, you do not want it to move. Now, what you can do, the very simple thing to do, is this code could be replaced by a simpler expression, which is if the value is between -5 and +5, then ignore it. Just don't pass it on or set it to 0. So if it's greater than -5 and less than +5, set the value to 0. And that just puts that spot in the middle where if you jiggle the joystick a little bit, nothing will happen. But here's the catch. What happens is that if you move the joystick slowly, imagine you're going in the positive direction and it's going 0, 1, 2, 3, 4. So you're still not outputting anything because you're in that dead spot. And then you move it up to the next point, it's 5. It's hit the edge of the dead spot now. You're still outputting 0. And then you move it to 6. And now you're out of the dead spot. So you do want the chair to move, but now the value is 6. So you're sending a value of 6 to the output. And from the controller's point of view, it's just jumped from a value of 0 to 6 with nothing in between. So you get a jerk when the chair starts. So the problem is that we don't just need to blank out the middle of the range. We actually need to split the range into 2 halves and move the halves apart so that when you move your joystick to 2, 3, 4, 5, and then when it gets to position 6, it actually outputs a value of 1. And then when you move it to 7, it outputs a value of 2. So you need to offset both the positive and negative parts of the range by the size of the dead spot. And that's what this code does. So, yeah, the fall through condition, if you're within the dead spot, is you output a value of 0. If you are, if the dead spot width is less than the position, then you subtract the width of the dead spot from the position. And the same thing for the negative value going the opposite direction. So what all this does is apply a dead spot and offset both sides of the joystick scale by the dead spot width. I either made no sense explaining that, or I over-explained it, and you're all thinking, why did I take so long explaining such a simple concept? Oh well. Yes. Oh, right. So... Oh, now I've got a note. Sorry, Peter. That was my computer doing a notification. Luckily, it was hidden by my face, by OBS, so you couldn't see what the notification was. Yeah. So, as Dodgy says, yes, it's a... How am I supposed to read that? That's a clever way to avoid the jerk. Yes. So that I am not being a jerk. And we're not applying any jerk to the start of the, the movement of the chair. It starts from 0, from the chair's point of view, it goes 0, 1, 2, 3, etc. It doesn't just go from 0 to 6. We start at 11. Now, what's the code for the squirrel? I don't know what that's about. All right. Chip says what the wheelchair can handle. How to do wheelchair burnouts then. Now, okay, there are two aspects to this. One, funny story. So Chris's brother, Nick, there are several stories, several relevant stories. Okay. When Nick loved doing burnouts in his chair, and it used to be that it was relatively easy with the early wheelchairs that they had. They were all relay controlled, and basically the way the motors were controlled, I don't think there was any proportional control at all. It was relays that just changed the like engaged power and changed the direction. So it was like both motors forward or both motors back, or one forward and one back, and that was all the control you had. And so Nick wanted the speed on his chair turned up as high as it could go, and he used to get in trouble in school by driving as fast as he could straight out the classroom door and then jamming the joystick across, which would make the chair spin and do like a power slide on the floor in the school hallway. And there's, I don't have it. I probably do have it somewhere, but there is a video around of him just basically doing donuts in his wheelchair. And then he was very disappointed when he discovered that the more advanced chairs have all sorts of restrictions built into them. They've got acceleration damping, and basically they prevent you, they go out of their way. It's like having driver assist in a car, traction control and anti-lock brakes and all of that sort of thing. And they prevent you from pushing the limits mechanically. The chairs could do a whole lot more, but the software in them has everything damped down. So one of the very first things he did when he got his, when they got the new Permobil chairs, the F5s, one of the first things he did was get a programmer. So normally they're locked down. It's a little bit like buying a car, and you can't change settings yourself. You have to go to an authorized service center, and they plug in a device and it talks via CAN bus to the chair controller, and you can change chair profiles and things, and they can have multiple speed profiles. So he got hold of a programmer and created one of the chair profiles that had every single parameter maxed out. It was like maximum acceleration, maximum braking, maximum rate of turn, etc. Yeah, so, oh yes, and the other thing that he did was he had a chair built backwards. I may be mistelling this story because I can't remember the specific details, but the way before the F5, the previous wheelchairs were done, you can have, I want to do a video about this because I think this is really interesting. The different geometries of wheelchairs, and whether you have a front drive, a mid drive, or a rear drive mechanism. And the base of the previous wheelchairs, he discovered that you could rotate it. So what he did, and I can't remember which way around it was, I think it was front drive chairs are faster and more agile, and he wanted to switch it around. So basically what he did was he had the chair rotated, the base of the chair rotated 180 degrees so that it switched from, I think it was like a slightly rear drive arrangement to a slightly front drive arrangement with dolly wheels front and back. So the wheelchair base was actually running backwards when he was going forwards, and the people at the wheelchair place had a fit, like trying to figure out what had been done, and they couldn't make it work. And they were insisting that. So what they were trying to do was make the chair controller understand that when you press forward on the joystick, it needs to move in that direction, which is reverse as far as the chair base is concerned. And so Peter, who is Chris and Nick's stepfather, said to them, just like swap the cables on the motors, make positive negative and negative positive. It'll fix the problem. And they refused to listen to him, and they spent, they had the chair for I think most of the day, messing around with all the settings, trying to configure the controller to make the chair understand that it was running backwards, and they just could not make it work. And in the end, they gave up and they swapped the wires, and then it was fine. So for a long time, Nick had a chair that was running backwards with the base reversed. So, yeah. Chip says front drive would be more stable. Well, the interesting thing is that front drive is more agile. And the way I describe this, for anyone that's driven a forklift, so if you haven't driven a forklift, it might seem really bizarre. In a normal car, you have driving wheels. Doesn't matter if they're front or back drive. It doesn't matter, or four-wheel drive. That's irrelevant. So you have fixed wheels at the back, and you have wheels at the front that steer. So if you drive a car, that is kind of what you come to expect. You just think of, like, I turn the steering wheel and the front wheels turn. So our concept of the geometry of the way a vehicle moves is based on front wheel steering. And so when you turn the steering wheel of the car, the front of the car starts to go around the corner, and the rest of the car follows, or whatever the vehicle is. Now, with a forklift, typically they are very different. What they do is they have rear wheel steering. So if you are in a forklift and you turn the wheel to the right, it is not the front of the forklift that goes around the corner. It's the back of the forklift that steps out in the opposite direction and angles it. And the reason it's done like that is that it allows you to pivot around the front wheels instead of pivoting around the back wheels. So you can pick up a load and come up beside a truck or, a pallet rack or whatever, and turn to the right, and the forklift will spin. It'll pivot around the front wheels because the back wheels are moving sideways. Terrible explanation. But anyway, all of this stuff is really interesting. And that is how front drive wheelchairs work, because they use skid steer, not active steering. So they do skid steer on the front wheels that are fixed. The wheels on the back are dolly wheels that just follow. So the result is that a front wheel drive wheelchair has the agility of a forklift, and you can drive up to an object, like say up to a table, and then spin sideways and end up parked right next to the table, which you can't do in a rear drive system unless you back up to it. So, it's the whole thing. In fact, if you drive a car, the way to think of it, it's like parallel parking. The way we parallel park is by driving past the parking space and then reversing into it, because the wheels that apply the steering are at the front of the car, and then you can swing the front of the car wide, drive it in, and then swing the front of the car in. If you try to parallel park by driving into the spot from the back, typically you end up having to, jiggle around a bit to get the car into position, because you can't scoot the back wheels in the same way as you can when you're reversing into the parking spot. You can scoot the front wheels in. And wheelchairs are exactly the same, but backwards. Well, not backwards. Exactly the same, but opposite. So steering from the back instead of steering from the front. And yeah, that's Dodgy says, shortens your turning circle. Yes. Aaron says, steering like a rocket. Yes. Cool. Now, Chip says, I've made a serious career out of driving. I think you explained it pretty well. Thank you. Scott says, they actually steer like a tank with very short tracks. Kind of, but it's more complicated than that, because they skid steer, but only from one end. Unless you have a mid-drive wheelchair, then yes, it steers exactly like a tank. Many wheelchairs are mid-drive, but that has disadvantages. It has a few different disadvantages. I could get into that as well, but I think I've probably talked about this enough. Now, yes. Now, but anyway, as I was saying, what I've been thinking of doing recently is I've just been talking to Chris about this as well. I want to do a wheelchair hacking 101 video. Something that's like a real introduction to it, and it explains a couple of things: the geometry of wheelchairs, and ideally with some nice little animations to show the different steering mechanisms, like how skid steering works and the difference in the way chairs turn with front drive versus mid drive versus rear drive arrangements, and also the major components like the motion controller, the user interface, the input controller, and how they communicate with each other, how to send new commands to them, etc. All of that stuff. I'd really like to do a video which is wheelchair hacking 101. Just with the basics to get people started if they're interested in this sort of thing. And one of the things that I've seen, I think I'm thinking about a Venn diagram here. The Venn diagram of people who, what are the circles going to be? People who care about wheelchairs, and people who have experience with control systems. The intersection is very, very narrow. And so what I've seen, just observing this over the last few years of working on things with Nick and Chris, is a lot of the time when people are faced with a problem like modifying a wheelchair, they have that problem not because it is their job. They have this thing that they want to do because they or their child or their parent or whoever is dependent on the wheelchair for day-to-day life. And so the result is that you get a lot of people who are total technical amateurs who want to do these sorts of projects, but there's no documentation. The systems that you're working with are very closed. There are no tutorials. So the hurdle of getting into things like even minor modifications to a wheelchair to make it better suit the needs of the person who uses it it's a really big barrier. And the people who are trying to do this because they need it done are not necessarily technical. And so I really like the idea of approaching this from the technical point of view and trying to explain it and do little intros and things that will then help the people who are faced with these issues and want to get stuff done. Yeah. So I think that's the idea of things like Wheelchair Hacking 101 or really basic explanations of things. Like I've just been talking about the geometry of wheelchairs, for example, and the different steering mechanisms of front drive versus mid drive, etc. For someone like the parent of a child who has just been diagnosed with muscular dystrophy, or someone who has had an accident and their life has changed dramatically and now all of a sudden they rely on a wheelchair, whereas before they didn't. Wheelchairs had never crossed their mind, they'd never thought about them. They're not necessarily in a really good position to be able to make informed decisions because they haven't ever stopped to think about the different geometries of drive mechanisms, or does this particular system interface with things in a way that's useful to me? And being thrown into that sort of situation and have to make decisions without understanding what it is that you're trying to, you're trying to figure out must be a really, really stressful situation. So yeah, as I said, I like the idea of doing videos that are aimed at that real basic level of an explainer of why do some wheelchairs have front drive, why do some have mid drive, doesn't matter, should you care, that sort of thing. I think that'd be cool. And then getting into projects like this one of, okay, so how do we hack this wheelchair and control it from a game controller, and explain how all of this works. So, I was about to show you Aaron's UT61 thing, and I am going to do that. But first, this whole train of thought, what I've just been thinking about is it's made me think of something that I was just thinking about last night. I was actually thinking about bringing this up on the live stream. And it's an issue about the types of videos that I do and where to go with this. Okay, now I've got this 2-year conversion mini-series I've been working on. Which started off as a single big video. I've sliced it, released the first 2 parts as part 1 and part 2 of the 2-year conversion series, and part 3 was meant to come out like a week later because I already had that basically filmed. And over the last couple of weeks since then, I've been going back and tidying up. Can I hit mute? Yeah, I'm just going to do that work. Yes. I'm going to mute my computer. I've been going back and tidying that up. And the reason that it's taken a couple of weeks, obviously not a couple of weeks full time, I've been trying to fit it in between other things and dealing with my computer not behaving as it should. And now, thanks to all of your support, I'm on the path to fixing that problem. And I've just got to say, running Final Cut Pro on a computer that is not 9 years old, so much better. I was just editing the video yesterday on the M1 and it is a dream in comparison. Like scrolling through the timeline, it's smooth, it doesn't jump all over the place. Yeah, it's actually going to make it kind of a pleasure to edit videos again. And so, where was I going with this? Okay. So last night, I've been going through this part 3 video, and part of the reason that it hasn't come out yet is that I don't like it. And I've been refilming parts of it, and it seems like the more I refilm parts of it, the worse it gets. It's got to, you know, sometimes you're working on projects where you get to the point where it's like, I hate this. No, not hate is too strong a word. It's not that I hate it. It's that I was, as it was a few weeks ago, it really just needed a little bit of wrap up at the end, and I could have released it, and it would have been like a 9 or 10 minute tutorial, but it really was not, it didn't show the things I wanted it to show. And so as I was editing it last night, so I was filming more for it last night, like refilming parts that I've already done. And there are parts of it that I've recorded like a few times, trying to make it better. And then I was sitting there watching it and thinking, I still don't like it. It's, anyway. And then as I was doing it, I suddenly, you know, sometimes your brain overlooks things and skirts around an issue, and then suddenly it's like, oh, now I understand. So what I realized last night is that the sorts of videos that I've done in recent times for the Superhouse channel have been not really the type of video that I like making, because they're not really project based. What I really want to do is, like, I think back to some of the videos that I did a while ago, like a couple of years ago, and they just seemed like they were more of a pleasure to make, and it was more just me talking. It wasn't, well, that sounds bad. If you look at the Final Cut Pro timeline on videos that I've been doing recently, like the ones that I've done in the last year or two, they are cut into, the timeline is lots and lots of little slices, like dozens or like 100 or more little segments, and it's got multiple layers and multiple camera views. So I'm doing multicam recording and then switching views as I'm working on it, and the timeline ends up looking like a whole lot of little things all chopped together, and I'll spend way too much time scrolling around, zooming in the timeline and trimming it and editing all the things so that it looks like, so this thing that I've recorded over the space of weeks looks like it was all done in a single 20-minute take, when it wasn't. Not by a long shot. It's actually like a patchwork quilt of little bits and pieces, and I think that has taken a whole lot of the, it's made it work basically. So it's like having a job of, oh, okay, I've got to record this and I have to explain this in a certain way and plan out the structure, and then I've got to record this bit and then edit it, and then no, this doesn't work, so I've got to re-record that part, and yeah, it's just become a pain. So what I want to do is do more project-based videos, and I haven't really done one for a while. I began, like the air quality sensor series, I think was part of the transition into this way of doing it, because with that one, as I was editing it, I had lots of explanation about how air quality sensors work. Like I did the little diagrams with the laser scattering, particulate matter sensors, and yeah, and all of that sort of stuff. So it was a project-based video, but it was transitioning into this thing that I've been doing more recently of spending most of my time in Keynote, believe it or not. So all of the graphics, the visuals that are used for things like like when I did the Unify Wi-Fi thing with diagrams of all of the different parts of the network, basically all the diagrams and all of the things, the pinouts, everything that you see in all of my recent videos, it's all done in Keynote. Because I use that for, it's really, really useful for just putting shapes on the screen and spacing them out. Like, let's see, I'm just gonna quit out of Eagle. What have we got? Okay, where is something? What am I looking for? Source files. Let's reveal. What am I looking for here? Superhouse. This is some of the source, some of the files. Grafana, no, serial conversion. That's what I'm looking for. Okay, just as an example, to your serial conversion. Now this is the, so yeah, I use this for doing all sorts of diagrams. Is it opening? I honestly don't know. Keynote, are you opening? Did it even detect my click? Open? I think it's opening. Keynote, yes it is. Cool. So yeah, I actually really, really like Keynote. It's one of those things where it's a tool that I've used for things that there is no way it was designed for originally. But things like this, you know, pinout diagrams showing the module and where the different connections are. It's fantastic for this because you can just grab shapes and drag them onto the screen and space them out evenly and, you know, do all these different things. So, you know, show where the connections are on this. Anyway, I love Keynote for this sort of thing. And yeah, for that. So anyway, what I end up doing is when I'm working on videos, I actually spend a very large amount of time, many, many hours in Keynote making diagrams like this so that I can then pull them into Final Cut Pro and include them in the video with a voiceover. So, yes, a lot of effort editing, yeah. And I've had a couple of people offer to do editing for me, and that is a very generous offer. Oh, and just another example, more pinout diagrams. Like this is diagrams of how to connect different things to your modules, like how to make up stuff. Anyway, I was just going to show you the real thing, but no. So the point of all of this is, what I want to do is more project-based stuff because I like building things. That's really what I care about. Okay, so Dodgy said, just going back to the wheelchair for a second, how do you address using the onboard remote control without disconnecting it? I'll answer that question, Dodgy, but Matt just said it can be a slow, just to wrap up the editing things, I didn't finish that train of thought. It can be as slow asking someone else to do editing as it is doing it yourself. Yeah, and also the major reason, there are packages around that allow collaborative online editing. So DaVinci Resolve, well, Blackmagic Resolve as it is now, I think allows that. So what you can do is you can have a shared project, like a video editing project online, and you can have an editor in one country looking at your footage, like in a different country looking at your footage and doing the editing. And it does a very clever way of doing it. So what it does is create proxy footage, which is lower resolution and much smaller file size. So the editor can do their editing and get all of the timeline sorted, and they do that using proxy footage. And then when they save it, you can apply the timeline to the original footage and it comes out in original full resolution and looks fantastic. So there are tools around that will allow things like collaborative editing, but the problem is the way I've been working particularly recently is that I would need the editor here in the room with me talking to me while I'm doing it, because what will happen is that I will record like a 30-second segment and then pull it into Final Cut and adjust stuff in the timeline and then think, no, it's not quite right. I needed to say something different. So I'll then just turn around, hit record, record the segment again, pull it into Final Cut, edit it, and then, yeah, it's a very tight circle. Like I'm recording and editing basically as I go. It's not a matter of sit down, record all the footage, hand it to someone and say, here, edit this, because the footage isn't done. I'm recording the footage as I'm editing it all. So now to get back to Dodgy said, back to the wheelchair for a second, how do you address using the onboard remote control without disconnecting it? All right, so what I do now, I haven't actually done it. Okay, so in my head, I'm going around how to explain this in a succinct way, because it is not a simple answer. All right, two scenarios. One scenario is you want to keep using the existing joystick on the chair. And in that case, what you need to be able to do is take the input from the chair. In fact, let's go back into Eagle. You want to be able to interpose between the original joystick and the chair controller. So you want a thing that will stick in the middle, and that is exactly what we did with the Chair Breakout Mini. No, not clients. Ooh, I shouldn't have shown you that. Projects, let's do, everybody please look into the red light and erase your memory from a moment ago. So yeah, Chair Breakout Mini, this one here. Hardware, and this particular board has an input on one side, which is the DB9 connector, and an output on the other side, which is also the DB9 connector, and it does a bunch of stuff in the middle. So the idea is that what you do with this is you unplug the original joystick from the chair, you plug it into this box instead, and then you have a cable that goes from this box into the chair. And then with this switch in the down position, you're just passing the signal straight through. So you can use the original joystick and the chair doesn't know any different. The joystick doesn't know any different. It's just direct control. But flick the switch the other way and we take over. And instead of the joystick signal just being passed through, what we do is read the joystick signal, which allows us to do other things like send the values out on CAN bus or send them to a FlySky transmitter. This is actually how we did the FlySky transmitter interface. CAN bus off this going into the transmitter. And we can also fake the input. Now in this particular case, well, in this one, we can't fake the input. So this is a different type of project. This is a way of intercepting the chair controls and allowing those chair controls to either control the chair or be sent off to something else that we care about and use it to fly a drone or an airplane or drive a car or something. So with this one, where were we? Schematic. Everything's on, it's a relatively simple thing. Everything is just jammed on one sheet in this project. So we've got the thing in here. So what this does is this box acts as a shim, really. It links in between the existing joystick and the chair controller. And it does all of this other stuff, which I won't go into. The summary is it can read what the joystick is doing, and then based on that, it can do other stuff. So send values out over CAN bus or whatever you want to do. So in that case, what we're doing is allowing the original chair joystick to remain in place. Now, with the, what am I looking for? That. So with the PWC, which is the project, PWC, yes. Alphabet, good. With the PWC, do you want to load? Yes. We are not using the original joystick at all. So this cuts it out of the loop. What it does is have the I2C joystick input, which you can't see, up here in this corner. So we've got the 0 stick input, or we've got inputs from other things. But we're not accepting the input from the original chair controller. We're just replacing it entirely and using our own joystick. So it's a different application. Now, if you took those two projects and you mashed them together, then you would have the ultimate in flexibility, because you could have the original joystick plugged in, and I'm just thinking about this. Funny thing is, you could take the two boards and just plug them together. That would actually achieve something. But yeah, if you wanted to use the original joystick and be able to intercept the signals and send them elsewhere, and be able to cut it off and send alternate signals like this one can do, then that could be achieved. We'd need to make a board that really just combines the features of those two things together. So we need an input on this side, which is where we would read from the original chair joystick, and an output on this side. But then we would want to do our own I2C stuff here to send output signals. I have no idea if I even answered your question. All right, storyboard. Yeah. What do you mean about storyboards, Peter? I am very interested to hear. So, now, okay, getting back to this whole video thing, and Matt just made a comment about reason is that you're often working out what you're going to do whilst actually doing it. Yes, and that has bitten me when I've been... Okay, I'm going to show you something else. Let's go into... there are not 4 W's on Superhouse. Let's go to this. And the other aspect that I hadn't even mentioned yet is that I am also simultaneously writing an actual written tutorial while working on the video. So I am recording the video and editing it and writing the tutorial. Page unresponsive. No, that's just the computer being slow. Wait. Web browsing is too much for it sometimes. It's getting there, I think. I am tempted to hit enter again to reload, but then it's just gonna... Yeah, I'm going to. Go! Because what I wanted to do was show you the password protected tutorial page for the current video. Anyway. Write a vague script, storyboard it to show how the video should look, shoot it, and then any editor with a script and a storyboard can bang it together. Ah, right, okay, so you're saying that I should be using storyboards. Yeah, that would actually help. In fact, in some ways what I'm doing is using, where are we? All posts. Yes, you're looking at the admin back end of this. Let's just view this one. So this is currently password protected, but because I'm logged in as the admin, I can view it. And in fact, if you are a Patreon supporter or a GitHub sponsor, and you have the current discount code, you can use it to get into this page, even though it's not ready yet. It's showing up on the site with a little password box on it. So if you stick in your discount code, which has already been emailed out for this quarter, then you can view this. So this is, this is the written tutorial. So what I've found in doing this is that writing the tutorial has actually forced me to go back and re-record some video, because writing it down helps force a structure. And sometimes when I'm recording video, I will just do like, oh, I think I'll talk about this and then this and then this. And then when it comes time to actually write the page that goes with it, I realize that the sequence doesn't make a whole lot of sense. And that is actually what's tripped me up on this very video. So what I've got in here is resources like links to the data sheets for all the different, let's do some zoomage, for all the different 2-year modules with ESPs on them. And there's an explanation of bootloader mode, which this diagram, yes, the schematic was done in Eagle, but then I then pulled this into Keynote and did the arrows and annotations and things. So explanation of how to get into bootloader mode, all the pins you need to control in order to reflash it, how to identify different types of 2-year modules, and I then got connections for all the different really common ESP based modules, showing where the pins are for power and reflashing. So with this you can find the connections. So if you open up a product, you can identify the module, and then this shows you where all the connections are, even for the ESP32 based module. I've never actually seen this. I would be very curious to know what product has a Taiwa 3 SE in it. I've never seen one. And there's a section there that still needs to be written about Tasmatizer. This is really the crux, so I'll get back to that. So jumper wires, showing jumper wire connections and stuff, and there's more to write at the bottom. So storyboards. So this really shows part of the crux of the problem with, so what I'm doing is writing this sequence, writing the instructions kind of like a storyboard, but it's in words. And then the video is the video version of this sequence from top to bottom. And this is what tripped me up, because what I wanted to do was show 2 different types of connections. One using an adapter like an ESP flasher or a modified D1 Mini, or there are others, which enable you to control GPIO 0 and flash, etc., so that you can do auto reset of the target, or connecting an FTDI adapter and then using a jumper so that you link GPIO 0 to ground to force it to go into bootloader mode. And those 2 methods are different enough that it actually warrants doing the instructions twice, I think. And this is the thing that I've been going, that has really stuffed me up basically with this latest video, and it's why I've been editing it over and over again, because my original, with the first version that I did, like the short 9-minute version, what I did was I got to the part of the video where I show making the connections to the device. In fact, it's I've got stuff right here. Let's switch to the handy dandy overhead camera. And this is from working on the video. So you can see this is a wiring harness that plugs into an ESP flasher, and then it's got the connection soldered onto the back of the ESP, like the 2-year module on there. And then this is another wiring harness, which is for an FTDI converter. Same sort of thing. So the way I was filming this is, in my first version, I soldered all of these connections in place for the ESP flasher, and including connecting up GPIO 0 on here so that it can do its auto reset. And then in the video, I just said, if you're not using an ESP flasher and instead using an FTDI adapter, get a short jumper wire, solder it onto GPIO 0 and connect it to ground. And then later in the process, with the FTDI adapter, you have to disconnect that, but with the ESP flasher you don't, because it handles the auto reset, like as you're doing the configuration in Tasmatizer. So what ended up happening is that there are 2 sequences of instructions. One sequence of instructions when you can do auto reset, and one sequence of instructions when you can't do auto reset. And I was trying to explain both of them at the same time. So I was saying, do this, and then if you are using this, then do this. And if you're not, then don't. And the whole thing just became really confusing. But the thing is that the process is similar enough both ways that it seems silly to run. It's like making two videos where 90% of it is the same. It seemed silly to go through, okay, now I'm going to show you the entire process if you can do auto reset. And then I'm going to show you the entire process if you can't do auto reset. And so that's probably the major structural change that I was just working on last night with that video. I have come to the conclusion that I have to show the whole process twice. And that means filming the whole thing twice with slight differences. And it was really in writing these instructions, like trying to write this out, that it became obvious. Because in the sequence, you have to write down, like there's an example back up here, I think. Yeah. So these are the instructions for how to put it into bootloader mode. One, if you have access to the reset pin, and the other one if you don't have access to the reset pin. So one is just power cycling and the other one is using reset. Now the same thing occurs if you can control GPIO 0 automatically versus if you can't. It's like a fork in the road, and then you need two different sequences. It's all very confusing. Such a rambly live stream today. Anyway, let's get on to something cool. Now, I am going to show you something that Aaron has been working on, and he had to do a forked video, yeah. Matt, you've made a very good point here. Is it possible that people like to be inspired by ideas more than be shown processes? It's certainly why I come and watch you. Well, thank you, Matt. Yes, that is a really succinct way of putting it, and that comes back to what I was talking about before with the earlier videos that were more project, well, not so much project oriented. I think that's what I was trying to explain when I said I wanted to build stuff. The problem with these very specific instructional videos is that it is a follow the bouncing ball sequence. It's a case, things like the Tasmatizer video that I did a little while ago, I think of them as utility videos. It's a sequential tutorial that shows you how to do something specific. And I don't find that interesting. It's useful, but it's not interesting to make. And I don't think it's that interesting to watch because it's just something that you use to get to the end result. It's like, I want to reflash this. How do I do it? Follow these steps and the job is done. And so that's why I think I'm finding it very unsatisfying to make those sorts of videos. I would much rather make videos that are talking about explaining things, not instructing things. And I think that's where some of the project videos can be good, because the project videos are a vehicle for explaining things. It's not just do these steps to build this thing. I really like to come at it more from the point of view of, why am I building this thing in this way? How does this work? Like, what is the concept behind this? So thanks, Matt. You put that very succinctly, and I think that really helps clarify in my own mind the sorts of things that I want to do and the focus that I need to have to both enjoy making the videos and to make them enjoyable, I suppose. Now, okay, so the UT61 thing, I'm just going to close that off so that I am not tempted to, in fact, close this off. so that I am not tempted to go back to that. Now, is it that one or is it that one? This one. This video, Aaron has been working on software for the UT61E project because there are a few different building blocks to this. All of the stuff that I've been doing with the little adapter that plugs into the multimeter is just about reading the raw bit stream coming from the multimeter controller. And that gives us raw data, but the raw data has to be processed to be able to extract the information. Like the basic packet is, 14 bytes or however long it is. We need to interpret those bytes to get information like what mode is it in, what range is it in, what's the sign of the value, what is the value that's coming out of it. So that's the parsing part of it. That is part of the problem, still to be done. Well, it's been done by other people. I want to incorporate it into the firmware that runs on the D1 Mini so that the values we get out of it have been pre-parsed. There are two different ways we can deal with this. We can take the raw packet and just spit it out and then put the burden of parsing the packet onto whatever software is going to be displaying the values, or we can pre-parse it within the adapter and then output the result, which is I am in volts range, I'm in volts mode, and I'm in this range, and I have a reading of X, and it is positive. Useful things like that. And then the software that is going to display that doesn't need to do all of that parsing. It just gets the already interpreted values, and then it can just worry about displaying it. I think that's a much better way of doing it. So my plan is to output both the raw packet and also a parsed version of the values, so that if you do want to process it externally, you can, or if you want to make some kind of user interface that displays the values, or you might want to pull it into Node-RED and then stick it into InfluxDB and then chart values over time, or all sorts of different things. Lots of ways you could use this. Then I want that to be as simple as possible, and you shouldn't put the burden of parsing the packet onto every implementation of the user interface. So that's my reasoning behind it. And so Aaron has been working on a couple of ideas about how to make user interfaces for this, which look incredible. And Aaron's original idea was to make a desktop app, essentially. Why did I just say that? This is a sign that my brain has finally given in. The whole idea of software being called apps, for some reason it grates. Because to me, an app is a specific type of software that runs on a mobile device, like a phone. And so the idea of calling a piece of software that runs on a computer an app, yeah, it's an application, but it just seems weird to me. And now it came out of my mouth without me even thinking about it. Okay, so like just the phrase desktop app, it seems like a, what is it? A tautology. So anyway, Aaron's original idea was to make desktop software which accepts the values from the multimeter and displays them. And then recently he's been doing this as a really cool looking little thing in Node-RED, and I like this a lot. So I'm just going to hit play on this video. I might end up playing it a couple of times just so you get a chance to see what's going on. So on the right, what you can see is an MQTT client, and it is publishing to this particular topic. So tele UT61E JSON, and it's sending a JSON message, and you can see here it's got current type AC, unit V, value to whatever he's changing it there in the video, and then negative is true. So this message that's being sent is an example of what you would get out of the meter. So the meter sends you the raw packet, and then we're going to parse the packet and then generate some kind of a JSON message, which includes things like the range and the value. So what it's doing in this video is manually creating the JSON message and publishing it to MQTT, and then the thing on the left is displaying it. You can see each time he clicks publish, so it's changing the values, clicks publish, and then the display on the left changes. And this display looks really cool. I like this a lot. And so this is being done as a Node-RED, what's the term? I can't remember. I'm not enough of a Node-RED aficionado to know all the details. But basically what he's done is created a custom node which generates this user interface, and it's available at its own endpoint within, so this is instructions for how to do the setup. And so Aaron shared this with me privately, but then I got permission to show you well, hopefully there's nothing revealed here like passwords or anything. But basically this is showing the sequence of setup of importing the definition for this particular node. So it's in a palette, I think it is. It's a palette item, whatever the thing is. So it imported a bunch of nodes and different things. And what this does is create an endpoint. So you can go to the Node-RED server in the browser and add /ut61e on the end, as you'll see in just a moment. And that then opens up the... Hang on. Aaron, were you doing this at 2:01 in the morning? Oh, you should have been asleep. Yes. Yeah, so, yes, as Scott says, application. Yep. As Scott says, the ESP has more than enough power to process internally. Absolutely, definitely. And other people have done it. Like, you can do it on a much slower processor than an ESP32. We're only talking about 2 packets a second. It's 14 bytes, and all you're doing is parsing to look at the bytes in specific positions and then looking up a thing. Like if it's this value, then it means we're in volts range. If it's this value, it means we're in amps, mode or whatever. So the actual parsing, oh, there you saw, hang on, I'm going to go back a little bit. Back here, because this is the cool bit. So now you can see, I'm going to hit pause here, you can see that in this browser window, it's going to be very small for you, so you won't really be able to read anything here. But this is node-red.local, so all he's doing is hitting his Node-RED installation with /ut61e on the end of the URL, and it opens with this as the user interface, which is so cool. And it's been configured to receive its data from this MQTT subscription. So this basically achieves exactly the end result of what I was wanting, and it does it all just in a browser window, which, as you can see there, you can then just resize it, and then publishing values to MQTT causes that display to be updated, which is, I think this is great. And I really like the idea of having multiple ways of representing this data. So Aaron was talking about doing a like a standalone desktop program originally, and he's already done a bit of messing around with that, like set up the user interface, and it looks exactly like this. But also being able to take that data into Node-RED and display it. I'm not sure what that was. I haven't actually watched right to the end of this video, so I don't know where it goes from here. Oh, okay. It's just showing the multimeter interface. So this is the sequence of setting up the items in the palette that Aaron has created. Yeah, and I'd like it if other people had a go at this as well. Now, one thing that we haven't absolutely finalized on is the structure of the JSON message that's going to include the information coming from the multimeter. So because that hasn't been implemented in the firmware in the D1, what Aaron has done is just come up with what he thinks is the way that should be structured. So if I come back to here, you can see in the setup down here, he's defined the payload as current type DC, unit V, value, blah, negative, false. So I don't see anything wrong with that. That structure seems okay to me. And so what we just need to do is make sure we standardize on how this information is going to be reported from the multimeter, like how the JSON is going to be structured. And then once that's defined, what would be good, maybe I should, I'm just thinking about the sequence. I want to implement the parsing at the multimeter side, but I think before implementing the parsing, it would be worth defining the structure. So that really is then going to define what we are working towards. You know, it's pretty normal in projects like this where you just start coding and you write something and then you end up not documenting it, or the code is the documentation, you know, all the usual things. But it would be really nice, I think, in this case. What I might do is I'll just take what Aaron has done here and I'm going to stick that into the README of the hang on, there is a standard already. Time of day. There is a standard already. I don't know what that's referring to. Maybe there is a standard? Yes. So, I don't know. Anyway, if we take what Aaron has done here and just put it into the README for the project as a definition of how that... Can you hear my stomach? Peter, my stomach got in before you. What is the time? 11:48. So, as I said to Peter this morning on Twitter, if he's not here in the live stream to remind me to stop for lunch, then I'll just keep live streaming until the heat death of the universe. But I think my stomach might stop me first anyway. So, what was I saying? That's right. SCPI, pronounced Skippy. Aha, okay. Cool, yes. So SCPI, I have heard of that, but I don't really know anything much about it. SCPI command. It's used with, it's GPIB, isn't it? Is that what used to be GPIB? Because I've used GPIB way back in, yes, Peter, in my tum-tum. Skippy, way back like 25, 30 years ago. While it was originally created for the GPIB bus, Skippy can also be used with RS-232. Oh, okay. So it's the protocol that sits on top of it. Interesting. Okay. Now I'm reading text on a screen that you probably can't read. So, yes. It's a standard commands for programmable instruments. Now, Skippy commands are ASCII textual strings. Yeah, so what we should do is support this as well. But I don't think it... Yeah, command structure, measure, voltage, blah. I would like to do this as well, not instead of reporting using JSON. Because one of the nice things about JSON is just that it's so universal. Like, there are libraries that deal with it really nicely, and Jack's text said, I thought there was a JSON standard as part of it. Maybe. Let's see. SCPI JSON. XML. Skippy, is there something better? I look at, I don't know, maybe there is. Let's go to Stack Overflow. Please excuse me while I read the definition of better. Okay, so this is interesting. So this comment says, where Skippy doesn't work well is if you need more complex data types or have large volumes of binary data to transfer. That's not relevant to us. If you are rolling your own, I'd look at JSON as a communications format. I don't know, what that suggests to me. Oh, and also Skippy is from 1999. How long has JSON been around? I don't think it existed in 1999. So I may be wrong, but just quickly looking through this, it looks like Skippy uses only straight ASCII, and yeah. Oh, my stomach. I would be amazed if you can't hear that. So, all right, well, thanks for pointing this one out. I hadn't thought of using Skippy. So, no, Jackstack, don't apologize, it's good. So what we should probably do, what I would like to do, is, come on. What I would like to do is add support for different formats, I suppose. If so what we could do is, from the firmware, we could output the raw packet for external parsing, we could output a JSON message, and we could output a Skippy format message if that was useful to anyone. I don't know. We could just publish the Skippy message to a topic, like to an MQTT topic, and then it could be dealt with in whatever way, shape or form, if that's useful. I don't personally have a use for a Skippy. I don't have any equipment that uses it, as far as I know. Maybe stuff I've got does support it. But if there are other people that can be using it, first JSON standard was published in 2013. Yeah, so it's a little bit newer than Skippy, which is from '99. Peter, what's that, Skip? Sonny's fallen down the well, but John has to go for lunch soon. Yeah, I'll leave Sonny down the well, and I will go off for a nice picnic lunch. I actually do need to wrap it up pretty much on time today, because I have someone coming over to visit, coming over for lunch, and I will need to be sort of out of here just after 12. Yeah, anyway, what was I doing? That's right. So Dropbox, projects, what was this one? UT61E. And I'm just going to write some notes on here. Let's get some more zoomage. What have I got? Ooh, notes. What have I got in notes? Lots of stuff. All right. JSON format based on Aaron's idea. Check out, I just saw someone mention Homey. Check out Homey JSON format. And also Skippy message format. Okay, so not quite a to-do list, but there are things. Okay. How dodgy. No, I don't actually have to, I don't have to run off now. Oh, well, in 5 minutes. Yes. Maybe what I should do, just moving that there, I'm going to, I know this is not the most efficient way of doing it, but what have we got? Also, I'm using an unfamiliar keyboard at the moment because I just switched my normal keyboard is down the back plugged into the M1 Mac Mini because that's what I was just that's what I was just messing around with, and I just got this, what is it, value, yes, I know, I could probably just be copying and pasting this out of the thing, negative, false, that'll do. Did I capture it? I think that's approximately the sort of thing that Aaron did. Anyway, what I want to do is transfer that more into, what's in the README? Yeah, in here, I might put some documentation. It doesn't really say very much. This README is very short. It just says what it is. So I need to add some documentation in here about the output formats. Anyway, wrong. Oh, I'm pressing the wrong. Yeah, the keys are not in the same place on this keyboard. Hang on, how do I get to Control D? No, Control D. There it is. Okay, I found the right key. Negative is a boolean, not a string. Okay. You are correct. Of course you are. I put it in quotes because I was not paying enough attention. I was, let's see, Superhouse projects, UT Vimnet. So I'll get rid of that quote and that. Okay. Negative, false, value. Is that all right? That's an interesting question. Charles said, why not value of minus 24.12? So the question is, why have negative as a specific separate attribute? I don't know. That would be... Ooh, Trevor said, emailed you a 3D printed case Wednesday morning. Check your spam. It's probably not in spam. It's probably just in my disaster of an inbox. Trevor, that is exciting. A 3D printable case for the adapter. So, hang on, I'm going to grab this, drag it over. Oh, maybe I should switch to overhead camera because you'll be able to see that much better anyway. So for the one that I've just been using, I've finally got some clear heat shrink in a large enough size to put over it. So this one, as you can see, is in heat shrink, which means that you can see the LED through it, and the reset button actually works very nicely through the heat shrink. And it means that there is no risk of shorting of anything touching this. But the idea of a 3D printable case for this is pretty cool. And I think I had a couple of people offer to design 3D printable cases for it. And Trevor, that is really cool. But I am going to have to wrap up this live stream and close that. Don't need that. I'm going to leave these open. Just minimize them. Oh, you can't even see what I'm doing. So I am going to... Oh, okay, so Aaron, I was sure Aaron would have a good reason for why negative is broken out as a separate attribute. Okay, so Aaron said it's how the meter passes it and also how the UI handles it. The 7-segment font is base 64 encoded to allow it to be shipped in the float.json, and so are the images. Yeah, values change position in the UI like the meter based on the number of points after the decimal. However, the minus symbol is always on the left. Yes, so I I knew there would be a reason for it. Now, Aaron, a question for you. Would you be open to the idea of having both versions in the JSON? So in the JSON, you would have the magnitude and the sign. So like 24.12, and the sign would be like negative, true or false. And also have another thing, which is the value, which is just like minus 24.12. And that way, if you're doing something like, what that actually does is minimize post-processing if you are treating it as just like a decimal value and sticking it into a database, for example. It means that if you're subscribed to this and you want to take it and extract a parameter and stuff it into InfluxDB, you could take the value attribute and use that instead of taking like the magnitude and then the sign and then doing some logic to see if it's negative value and then sticking that into the database. Cool. Okay. So Aaron, I definitely do understand why you are doing it now that you've explained it. So why you do it with the magnitude and the sign value. Maybe what we could do is, yeah, we might have to talk about this a little bit, but what I'd be inclined to do is change the label on what you currently have as the value and call it something like magnitude or what's the term, absolute value, like abs value, and so that's always going to be just a number. It'll be a positive number whether the reading is positive or negative, and then have another part of the message which is value, and that will be like minus 24.12 or 24.12. So yeah, we might have to talk about what we're going to name those attributes in a way that makes sense. But I think we can certainly handle presenting those different things in the message coming out of the D1 Mini. So we can take care of that pre-processing or the parsing in the firmware. All right, I am going to go. And there is some awesome work being done by people here. So Trevor, I'm going to check my email and find that 3D printable case. And Aaron, your adapter. So Aaron has been doing all of this without actually having the adapter or the multimeter. He doesn't have either of them, which is why he's generating the messages manually and publishing them and then parsing them. So it's very cool to see that. So Aaron has one of these in the mail heading his way, and has a multimeter, I believe, heading his way as well. So soon he'll have the actual gear. Peter's telling me to go home. Okay. Oh, Jacob, you have an awesome day too. Thanks for everyone that's come along. I didn't do a shout out to people at the start, but I won't do it now either. Thank you very much, and have a fantastic afternoon, or go to bed if it's currently 4 o'clock in the morning for you, which I know it is for a few. Yes, Aaron. We'll talk soon about the formatting of that thing. Okay, here we go. I've got the big button that says end. What I need, I did a project a while ago. Here we go, a squirrel right as I'm about to leave. A big e-stop button that I can just smack it and that ends the live stream. I think that's a project for the future. For now, I will settle for tapping this thing on the screen. Okay, thanks everyone. See ya. Yes.